Hello Wildcats, we're here to talk about solving systems of equations, as you can see over my right shoulder. There are actually multiple ways to solve systems of equations. There's solved by graphing, there's solved by substitution. This video is going to focus on solving by something called a linear combination. So again, the idea behind a system of equations is that we have more than one equation, and these equations have more than one variable. So you see right here that we have one equation which is x plus 8y equals 42, and we have a second equation which is 5x minus 8y is equal to negative 30. Now our goal is to find a value for x and a value for y that will fit not only the top equation but also the bottom equation. If we can find that ordered pair, if we can find that single value of x and that single value of y which fit both equations, then we've solved that system. And that's our idea here. So how are we going to do it? Well, linear combinations is just a fancy phrase for basically adding, subtracting, and multiplying. We're going to pick one or more of these options right here, and we're going to look at using these options to help us figure out what x and y can be equal to. Now, the idea basically is that right now this is a difficult problem because we have two equations and they each have two variables. Now, before you solve problems like these, you solve equations that have one variable. And it's just one equation as opposed to two equations. So that's what our goal ultimately is. How can we turn two equations with two variables into one equation with one variable? And the way that we're going to do that here is through addition. And the idea being that, yes, we can add numbers, and we can add variables, and we can add terms, and we can add expressions, and we can even add equations as well. And that's what's going to happen here. We're going to basically add down here. We are going to put a plus sign here. We're going to add these two equations. And say, well, why would we do that? Well, what happens when we add 8y and negative 8y? What's the result? Yeah, the result is 0. So that means there's no y's left. So by adding these equations, we are eliminating the y variable for the moment. So let's do this. So we have x, which is really 1x. We don't have the 1 right there. So x plus 5x, 1 plus 5 is 6. So this will be equal to 6x. And as we said here, 8y plus negative 8y, that's equal to 0. So they will wipe each other out. They are gone, and now we just need to keep our equal sign, and then we have to add the right side, because whatever we do to the left side, we want to do to the right side. So we have 42 plus the opposite of 30. That's going to come out to be 12. Now what have we done? We've taken these two orange equations, we've added them together, creating a brown equation that only has one variable, which means we can solve for that variable. We can figure out what x is. If 6x is equal to 12, well then we know that x would be 12 divided by 6. We're going to divide both sides by 6. 12 divided by 6 is 2. So x is equal to 2. All right. Well, we're halfway done. We have x, now we just need y. How do we go about that? Well, we're going to take our value for x, we're going to plug it back into one of our equations. You can plug it into the top equation or the bottom equation. It doesn't matter. You'll get the correct answer from either equation, assuming that your arithmetic is on target. So we have 2, instead of x, 2 plus 8y is equal to 42. All right, so 2 plus 8y is equal to 42. I'm going to kind of move down here now. If I subtract 2 from both sides, this 2 will go away on the left, but I also have to subtract 2 on the right. So 42 minus 2 would be 40. So we have 8y is equal to 40. And if 8y is equal to 40, we divide by 8, and we have y is equal to 40 divided by 8, which is equal to 5. So our final answer, which I'm going to sneak over here on the board, we have x is equal to 2, and y is equal to 5. So we can write that as an ordered pair, 2, 5, or we can have x equals 2 and y equals 5. But 2 and 5 fit both of the equations. Right? Now sometimes with a problem like this one over here in black, we can't add right away. If we add right away, we get 6x, and we get the opposite of y. Neither of the variables go away. If we subtract, once again, neither of the variables go away. 2 minus 4 is negative 2. Negative 3 minus 2 is negative 5. Our goal is to get one of the variables to wipe out. In order for that to happen by adding or subtracting, we need the same number in front of x or y. It doesn't matter whether the number is positive or negative, we just need the same number. We don't have that right here, but we can get it by multiplying. Okay? What if we were to multiply everything in the top row by 2. Okay? If we do that, that 2 is in essence being distributed to all three parts of the equation. 2 times 2x is 4x. 2 times negative 3y is negative 6y. 2 times negative 6 is negative 12. We've doubled everything in that top equation. Well, now look at our new system of equations. We're not going to really concern ourselves with this one anymore. Now we're going to focus on that one. We have the same number in front of both of the x terms, and therefore we have the ability to eliminate one of the variables like we did right here with the y's. How do we go about it? Well, we don't want to add this time because 4x plus 4x gives us 8x. The goal is to get x out, and in order to get x out, we need to subtract. So we're going to do the top equation minus the bottom equation. 4x minus 4x is 0. We don't have to write that. 2y minus negative 6y. 2 minus negative 6, we see that double negative in the middle. We're subtracting a negative number, which means we're adding. All right, so 2 minus negative 6 will give us 8. So we have 8y. Over here, 20 minus negative 12. Again, the double negative is a positive, so we're adding. 20 plus 12 is equal to 32. So 8y is equal to 32, and dividing both sides by 8 tells us that y is equal to 4. We're going to do the same thing that we did over here. Once we get one of our values, we're going to plug it into an equation to get our second value. In this case, we already know y, so we have to figure out what x is. So we can go back to any one of these three. They're all good numbers to work with. Let's go to this middle one right here. 4x plus 2y is equal to 20, but y is 4. So that tells us that 4x plus 2 times 4 is equal to 20. Okay, 2 times 4 is 8, so 4x plus 8 is equal to 20. And we can subtract 8 from both sides. And I'll get down to the bottom of the screen here. But we see that 20 minus 8, that's going to be 12. I'm going to move over this way. We got 12 right there. Because 20 minus 8 is 12. Those 8's are gone, leaving us with just 4x. So 4x is equal to 12, and we divide both sides by 4, so x is 3. So we have y is equal to 4, and x is equal to 3. And those are two good answers. And again, we can also write our answer as an ordered pair. And the ordered pair would be 3, 4. So again, the idea is start, if you can add or subtract right away, go for it. If not, then your first step will be to multiply one of the equations. So multiply first if necessary. Then you're going to either add or subtract to get rid of one of the variables. Once one of the variables is gone, solve for the remaining variable. Get y is equal to 4, or in this case, x was equal to 2. That was step 3. Step 4, use your answer from step 3 to figure out what the second variable will be equal to.